Okay, we are looking at radical equations part 2 from Kuta software. This one is titled quote unquote hard. So let's go ahead and jump in. I'll do a few problems here. So similar to part 1, we have to recognize that when we're dealing with an equation with a square root, we have to be thinking about using a square to undo it. Multiplication undoes division, addition undoes subtraction, squaring undoes square rooting. So if we look at this 110 minus n and seeing how it's under a square root, if we were to square both sides, that would allow us to cancel this square out with this square root. Now we get 110 minus n equals n squared. So now we're in the world of quadratics, right? So we want to set this up to look like a familiar quadratic formula. So we can add n to both sides. That'll give us 110 equals n squared plus n, right? We have 110 equals n squared plus n, and to put it in standard form of a quadratic, we want ax squared plus bx plus c. So we'll have to subtract 110 from both sides. And now we are in standard form, which should allow us to factor this to be able to solve. So we're trying to find two numbers that multiply to negative 110, and we can assume here with our, and I'll leave a little room there. This is n squared. We can call this plus 1n. So we need to find two numbers that when you multiply them, you get negative 110, and when you add them, you get positive 1 to factor this. So we can say 0 equals, it's going to be a pair of two numbers, right? And I'm noticing 10 and 11. 10 and 11 multiply to get to 110. We know that one of them has to be negative and one of them has to be positive in order to multiply to a negative number. So which one needs to be positive so that when you add them, you get a positive one? Well, the positive one would have to be the 11, and the negative one would have to be the 10. When you multiply negative 10 and positive 11, you get negative 110, and when you add those two, you get positive 1. So now, because we're setting this equal to 0 here, right? And these two parentheses, this one and this one, are being multiplied by each other. If either one of those parentheses equals 0, then the whole thing equals 0, because 0 times anything is 0. So we're asking ourselves, what do we have to put in here for n to make it so that this parenthesis is 0? What do we have to put in for n here so that this parenthesis is 0? Well, this one here, if we put n equals 10, 10 minus 10 is 0, and 0 times anything is 0. Similarly here, if we put it in a n equals negative 11, then negative 11 plus 11 equals 0. 0 times anything is 0. So our two solutions are n equals 10 and n equals negative 11. Okay, let's do one more, see if we can find something a little different. Um, let's just move down here to the bottom. We'll do number 13. Okay, whenever you're working with a square and you're trying to isolate a variable, you want to be thinking about squaring both sides. This square allows us to cancel out this square root. So we're now left with negative 16 plus 10a equals a squared. So first step, now we want it to look like standard form of a quadratic. So let's get our terms moved over. That will be a squared, or sorry, I'll leave my negative 16 over here. Negative 16 equals a squared minus 10a. Now we can add 16 to both sides. This allows us to be in our standard form where we have a squared minus 10a plus 16. Now we're asking ourselves, are there two numbers that when you multiply them together, you get 16, and when you add them together, you get negative 10? So we're looking for 0 equals, it's going to be two numbers. It's going to have to be two negatives so that when they add, they're negative, but when they multiply, they're positive. And just going down the menu of what multiplies to 16, I get, 4 and 4, or I see 8 and 2. So 8 and 2, when we multiply them, we get positive 16. And when we add them, we get negative 10. So I'll move this over here. When we're looking at 0 equals a minus 8, a minus 2, we're asking ourselves, what do we need to put in for a so that it equals 0? What do we need to put in for a so that it equals 0? Well, in this case, we would have a equals 8 because 8 minus 8 equals 0. And in this case, we would have a equals a positive 2 because 2 minus 2 equals 0. So our final solution here is a minus 8 and a, or I'm sorry, a equals 8 and a equals 2.